Hello and welcome to C Programming by IT Tools Training. In this session, we are going to start a new unit called Dynamic Memory Allocation. So, what is this dynamic memory allocation? Till now, what memory allocation we were using? What type of memory allocation with respect to integer, char, and all these things? First of all, most oftenly, we face situations in programming where the data is dynamic in nature. That is, the number of data items keep changing during the execution of the program. For example, consider a program for processing the list of customers of a bank. If a person is willing to open an account, the data item increases. Whereas if you want to cancel your account, it will be decreasing. If you are taking integer type of data or char type of data type for this, a specified memory will be allocated. That is called as static memory allocation. In these situations, we want dynamic memory allocation, whereas memory will be getting allocated during the run time of the program. In other words, user is going to define the memory allocation, the size of the memory. Okay. First of all, as a basic, we will try to know memory allocation process, how it works. Okay. Your global variables, program instructions in the sense C is equal to A plus B, all these kind of instructions, static variables, all these will be allocated in permanent storage area. And local variables inside the main, if you are declaring int A, B, C like that, it will get stored in stack. Okay. Apart from this, in between these two, permanent storage area and stack, you are having a memory region called as heap. We'll call that as heap, which is free memory area. These memory you can use for dynamic memory allocation. But you should remember one thing, that is the size of heap keeps on changing when the program is executed due to creation and death of variables that are local to functions and blocks. It depends on the program size, the content, and if you are executing, the task of that memory space will be done. That is the depth of the variables, like that. Also, there are chances like overflow during dynamic allocation process. There we should take care by giving null pointer. Okay, all these things we are going to discuss now. First of all, we'll try to understand memory allocation functions. What are the memory allocations functions? We can go with malloc. This is not with the capital. Malloc is there. Calloc is there. Free, realloc. Okay. Malloc in the sense which allocates request size of bytes. You are specifying the size of bytes, how much ever you want. So it allocates that much memory with respect to your request and returns a pointer to the first byte of the allocated space. So through a pointer only you can go with malloc function. Coming to calloc, it allocates space for an array. Remember, an array of elements initializes them to 0 first of all, and then returns a pointer to the memory. So if you are using calloc, it allocates the space for array and it initializes all the memory space with 0. Fine. Coming to free, it frees previously allocated space. If it is allocating with malloc, calloc and all, it frees the previously allocated space. Coming to realloc, it modifies the size of previously allocated space. So in this session, let us learn how to use malloc. Coming to malloc function, it's a predefined function in header file std library standard library.h. So I have to specify standard library.h. Then only malloc will get meaning. First of all, as initial thing, I want variables size of integer type and a pointer of integer type p and a array of integer type, it's a pointer array. Okay, now I'll ask you to enter the size for this array. This is an array, but I'm not giving size to that. It's not having specific size. We want to go with dynamic memory allocation, no? So you are choosing the size of the array. Enter the size. Percentage D, comma, size, ampersand. Now A is equal to, let us leave this, malloc size of size. Okay, this much you can understand. I'm giving dynamic memory allocation. I'm giving malloc. How much size I'm giving of size of function I'm using. But malloc is a function. In case of user defined function, you were specifying the data type of that, right? Int mul, int div, like that. Now for malloc also, even it is dynamic memory allocation, predefined function, you have to specify the data type of it. If you are not specifying, it is going to be void type. Now with respect to size, it is of integer type, right? How much you are going to enter the size, 10, 12, 5. That is the size of functions work. Okay, there are other ways to define this. What you can do is int type malloc size into size of size or integer. Like this also you can define. Okay, the meaning of this is integer type pointer. I'm using malloc function size into, say for example 5 into size of integer. Size of the integer is able to store this size, right? Even if you are giving 100 as your size of integer 4 bytes are enough to store that, right? That is why I'm mentioning size of integer. If you are giving, that is enough for me. Into 5 times means it's going to be 5 times more than that. Like this also you can specify. These are the different ways to go with malloc. That's all. Okay, both will, instead of this, if you are making this as comment, both will work in the same pattern. Fine. Now I want to know whether the memory of this much is available in the heap or not. Okay, for that what I'll do is A is equal to null. I'm checking. If it is the case, it should print a statement for me. No space available. you are requesting for the memory. If it is not available, if A is equal to null, that is, it's not going to allocate the memory, it's going to display no space available. Else, you can type your program now. What do you want? First of all, if you are getting confused with this, let us go with the first address, what it is going to allocate. Okay. Printf address of first byte is, let me type, okay, that is %u. I'm going with address, that is 5% u. After that, you can give new line if you want. And here I'm printing, so it is just A. I want address, that is why it is A, not star A. Star A means it will be giving value. Okay. After this, under a for loop, you can ask for entering the value. P is equal to A. P less than A plus size P plus plus. Okay, you know the meaning of this. Initially, whatever the address of A, from there, I'll start the loop until A plus 5, which is greater than P. Till then, I'll execute. A plus size is how much ever like size you are giving. If you are giving 5, A plus some 5 bytes. I mean, not 5. For integer, you are going to occupy 4 bytes, right? So if you are taking pointer, it will be A is a pointer, P is a pointer. So it will be incrementing, P will be incrementing with respect to size of the memory. Integer type means 4 bytes. 4 bytes, 4 times, sorry, 5 times it's going to get added. That much times we are going to run the loop. Fine. You will understand once I execute the program. I'll ask for %d, comma, p. Remember guys, even though it is scanf, it's a pointer. So just p, not ampersand. Okay. Now what I'm going to do is I'm going to print the same thing. So I copied that and pasted under the same condition, printf. Printf. What I want to print is %d is stored at the address %u. First of all, star p, I want the value, after that address. So in which memory address what is getting stored, you will understand properly. My bad again, it's not id, it is. Okay, fine, no errors. Enter the size, I'm going to enter as 5. Address of first byte is 632. You remember this much, that is enough. That is the starting address of the heap. Here I have not given any printf statements, so I'll start entering for array. 1 2 3 4 5. 1 is stored at the address 632. 2 is stored at 636. 4 bytes will be there for integer. 32 plus 4 is 36, plus 4 is 40, plus 4 44, 48. Fine. This is how you can allocate the memory dynamically during runtime. So user is defining the size of the array or size of anything. If you are using structure, size of that. Dynamically, data types size you are going to mention. Coming to the next type, that is calloc. Calloc is another memory allocation function that is normally used for requesting memory space at runtime for storing derived data types such as arrays and structures, which we have already seen with malloc. While malloc allocates a single block of storage space, calloc allocates multiple blocks of storage, each of the same size, and then set all bytes to 0. Each of the same size means if you are going with array of integer type, it will be useful, and initially it will set all the things to 0. Only difference between calloc and malloc is, okay, let me make this as comment. And let me copy this. Only one line change, that is why I'm showing here only. Instead of M, I'll make it as C, and here size, comma. That's all, guys. See, I'm going to define dynamically the memory space for size, for A or array, pointer array by using calloc. How I should define that? Same. Which type of memory allocation you are going with? Integer type. I'm using pointer, comma, size you should mention. N. Okay, that is nothing but size, comma, size of whatever you want to take, integer or size, it's your wish. Only the thing is N, comma, you should give that. That's all. Or N blocks you are going to define. We discussed it, no? Different blocks it's going to give. So I'm asking for N blocks, 5 blocks, like that. That's all. Fine. Now let us build this. Enter the size 5. It's showing the first address 40, you remember, that is more than enough. 40, 44, 48, 52, 56. So it is displaying as it was displaying with respect to malloc. Only the difference is number of blocks you're mentioning here. That is the size. That's all. Fine, guys. That's all about malloc, calloc I should address. That's it for this session. Thanks for watching.